foundation.
Hmm.
So as we know, pile foundation, where we use pile foundation, where black cotton soil, so we use a pile foundation. If black cotton, if soil is poor, then we use a pile foundation. So there are some criteria for pile foundation design as per IS 2911 2010. So the following Indian standard code can be referred to design to the pile foundation. There are some types for pile foundation. First, concrete pile. Second, timber pile. Third, underrim pile. And fourth, load test on pile. So, section 1 in a concrete pile, derived cast in situ concrete pile. Section 2, board cast in concrete situ pile. And section 3, derived precast concrete piles. Revised as per 2010. Some important changes in the code highlight as follow. So, first, minimum grade of concrete should be used as a N25. Design parameters with respect to adhesion factor, earth pressure coefficient, modulus of subgrade reaction rates have been revised to make them consistency with outcome of modern research and construction practice. Fourth, minimum dia of board cast and situ pile have been changed as 450 based on following parameter. There are some criteria for a clear cover over reinforced close 6 11 4 50 into 200 So there are some criterias. Fifth, provision for special use of large diameter board cast in situ reinforced cement concrete pile in a marine structure have been added. Procedure for calculation of bearing capacity, structural capacity, factor safety, lateral load capacity, overloading, it also have been modified to bring them at a part of present article. Practice. 7. Minimum time of curing before handling of precast pile has been modified. Provision has been made for use of any established dynamic pile. Deriving formula instead of recommending any specific formula to control the piling at site. Giving due to consideration or to limitation of various formula. There are some most important changes for an bearing pile uh, as per IS code 2009 2911 close 6.61. In case of pile founded on hard stratum and deriving pile their capacity mainly from end bearing, the minimum spacing shall be 2.5 times of the diameter of circumference ring circle corresponding to the cross section of the pile shaft. So we have take end bearing pile hard strata 2.5 D. After that, in case second case, pile resting on rope, the spacing of 2 times they say diameter may adopted. So pile resting on rock, we have take two times of diameter of the pile. And third case, pile deriving their load carrying capacity mainly from friction shall be spaced sufficiently apart to ensure that the zone of soil from which is the pile derived their support do not overlap to such an extent their bearing values are reduced. Generally, spacing in such case shall not be less than the diameter three times diameter of the shaft. So friction pile we have to use 3 times diameter of the pile. So and the reinforcement for longitudinal reinforcement, minimum 6 number of bar shall be used. Minimum dia of bar is 12 So I have take this example. A column size is 230 by 700 subjected to factor load 5,900 kilonewton. The ultimate pile capacity of each individual and bearing pile is 900 kilonewton. Where the diameter of pile take 500 material to be used M30 and Fe 500. Step 1. Determine the pile cap dimensions as per IS 299. So we have take column size 230 by 700, factor load PU is equal to 5,900, capacity of each individual pile 1,900 kilonewton, diameter of pile DP is 500 and material M30 and Fe 500. So first of all we have to find the number of pile. So we have to divide factor load divided by the capacity of individual each pile. So the 5,900 divided by 1,900. So we get 4 number of pile. Second, center to center distance between pile. Like this P1 to P2 distance between the pile. IS 2911 page 0.4 close 6.61 center to center distance between pile. There are some points we have already know. Deriving the capacity mainly, end-bearing pile minimum spacing shall be 2.5 times diameter of the circumscribed circle corresponding to the cross-section of the pile side. So we have take 2.5 times dp, 2.5 diameter of the pile 500. So we get the 12. Sorry, sir. Hello.
No issue, no issue. Perfect. You can.
Sir, I just need few
Okay.
minutes.
Okay, no issue. You can mute your mic. No issue. Okay. एंड इसके बाद गाइस आई थिंक हम लोग में से कौन रेडी है गाइस? प्रशांत रेडी है। एंड प्रशांत आप स्क्रीन शेयर ट्राई करना चाहोगे तब तक?
श्योर सर।
रुक रुक
Yes, sir. I'm ready.
रुक जाइए अभी इसके बाद आराम से करिए। ओके रिलैक्स, आराम से करो ब्रिंजल। कुछ काम है तो टेक योर टाइम, अदरवाइज यू कैन कंटिन्यू। अगर तुम्हें काम नहीं है तो कंटिन्यू, अदरवाइज क्या बोलते हैं करो। तुम्हें क्या करना, अभी टाइम लेना है कुछ?
नहीं सर, कंटिन्यू करना।
ओके करो। जस्ट गाइस सीखने का प्रयास करिएगा, तब ज़्यादा बेनिफिट मिलेगा। ओके कंटिन्यू।
So the center to center distance between pile we have take as per IS 2911 page number 4 close 6.6.1 center to center distance LCC 2.5 dp. So we take a center to center distance from between two piles is 1002 to 50 mm. Clear edge distance as per IS 29 page 0.6 close 6. The clear overhang of the pile can kept beyond the outermost pile in the group shall be a minimum of 150. The pile cap, the edge, and the diameter of the pile edge is a minimum 150 mm we should take. So I have taken to 50 mm. Effective clear edge distance. Effective clear edge distance is the center of the pile between the pile cap edge. 250 plus dp by 2, diameter of pile divided by 2, so we get 500. Now find the reaction of each pile. Reaction at under each pile are 5900 divided by 4. So, 4 is the number of piles required. So we get the reaction for one pile is 1475 km. Step 2. Trial depth of the pile cap. As per Varghese empirical expression, the thickness of the pile cap will be as a function of pile diameter. First formula, diameter of pile cap, d pile cap is equal to 2 diameter of pile plus 100. This formula is used when the dp is less than 550 mm. And second formula, d pile cap is equal to 1/3 into multiply 8 dp plus 600 when the dp is equal to or greater than 550 mm. So our pile diameter is 500. So we take first formula. As in a proposed example, the diameter of the pile is 500. Hence, empirical formula number 1 is needed to adopt for finding pile depth. D pile cap is equal to 2 times diameter of pile plus 100. So we get 110 mm. So now we adopting trial depth. The pile cap is 1200 mm. The depth of pile cap usually should not be less than of 600 mm. Now assuming clear cover is 60 mm. So we know for a foundation we use a 50 mm cover, right? But sometimes for this pile cap foundation, as per IS code 2911 2010, we use 60 mm cover. There is the close. The cap is generally cast over 75 mm thick leveling course of concrete. The clear cover block for main reinforcement in the cap's length shall not be less than 60 mm. So we have considered 60 mm cover. The diameter of bar is 20 mm. Effective depth of the pile cap, D effective, is equal to T minus clear cover minus dia half, 1200 divided by 60 minus 20 divided by 2. So we will get 1130 mm. Step 3. Design for flex rod. Bottom reinforcement along width of column. So we get formula mu is equal to 2 times reaction along the width. So LCC divided by 2 minus 2 times column width of column divided by 2. So 2 into reactions LCC 1.25 divided by 2, width of column divided by 2. So we get the reaction, we get the MU. Now B is 1000, D cap is 1130, and FCK M 30, FCK 30 MPa, and FY 500 MPa. So find out the AST. So there is a formula for AST. We get the AST 3214.67 mm square. AST minimum we take 12%. 12% into B into D. So we get 1140 mm. Providing T25 mm unit area of bar 490.87 mm, as we know formula pi by 4 d square for unit area of bar. Spacing required as required 490 unit area of bar divided by AST into 1000. So we get the spacing requirement as we provide spacing is less than 125 mm. We get if we provide above this, so sometimes we have get a problem. So we always take a minor minimum in this spacing. Provide T25 at 120 mm center to center along width of column. Area of steel provided AST 49.887 divided by 125. 125 is the spacing and 490.87 is the unit of bar into 1000 is equal to get the answer 3926.96 mm. PT is equal to AST area of steel provide P into D cap. D cap is the depth of cap 3926.96 divided by 1000 into 1130 into 100. So we get 0.3475 percentage. Now we have to find bottom reinforcement along the depth of column. First we have find the width of column. Now we have to find depth of column. So same procedure, but for same different depth of the column we use. So MU for formula 2 by R into LCC by 2 minus depth of column divided by 2. So we get 811.25 kN per meter. P is equal to 1000, D cap 1130, FCK 30, FI 500 mm. So we put the formula in this and we get AST 1693.52 mm square. Now we have to take 12% of minimum AST. So we get 1140 mm square. And now we already take this, so I think we don't want to repeat that. So we have start this spacing required over a width. We consider unit area of bar 419.87 providing T25. So 490.87 divided by 1693.52 as per AST minute AST into 1000. So we get 289.85. So we consider 275 mm center to center spacing. So provide 225 in 275 mm center to center along depth of column. Area of steel provided AST 4098.87 divided by 275 into 1000. So we get AST. For finding percentage, there are formula AST is equal to B into D cap. So get B 0.158%. Now we have to find top reinforcement along width and depth of column. There is no tensile force for hogging moment. Has minimum percentage of reinforcement needed to provide. So AST minimum we get 0.06% into B into D is equal to 0.6 percentage into 1000 into 1200 is equal to 720. Providing bar T12 mm on a unit area is 113.09. Spacing required over a length is equal to space required is equal to 113.09 divided by 720 into 1000 is equal to 157.06 mm. So we have to consider T12 at the rate 150 mm center to center along both the direction. Area of steel provided AST is equal to 113 divided by 09 divided by 150 into 1000. So we get 753.93 mm. We have to find PT. There are formulas, so we get the 0.067%. So there are some there is a Summary for flexural design. Location is bottom and top. Bottom direction along the width of column T25 at the 125 mm. We got 0.3475 along depth of column T25 at the 275 mm. 0.158 top along width of column and along depth of column. Same we are considering, and the percentage 0.067. Step 3. Design for checks here. Design for checks here. Check for punching shear along column. So first of all, we have to know about this clause. In a computer the external shear or any section through the footing supported on a pile. The entire section from any pile of diameter dp, though center is located dp more outside of the section, shall be assumed to produce shear on the section. The reaction of the pile, any pile, though center is located dp by 2 or more inside section, will be assumed as a produce no shear on the section. For intermediate position of the pile center, the portion of the pile reaction to be assumed as a producing shear on the section will be based on straight line interpolation between the full value of dp by 2 outside of the section and zero value dp by 2 inside of the section. So it's quite difficult. So there are some more figure. So first case is, say there is a critical section and the diameter of pile is outside of the dp by 2 area. Dp is the diameter of the pile divided by 2. So there is the outside so the pile is outside of the section. So we get so we consider the 100% of reaction. But the case 2 is said if critical if a pile or near inside the critical section and inside the dp by 2, so we don't take any reaction, we take zero reaction. But case 3 said that critical section, there are critical section but pile is nearby the critical section or under the dp by 2 area, so we take interpolation. There is a sum here, we take 0 and here we take 100 and find out the value of using interpolation method. So pile cap foundation. So pile cap foundation, you find we get reaction as per number of pile. So P1 1475 and we consider 39%. We find as using AutoCAD also, and shear reaction we multiplying a reaction into the percentage, we get the shear reaction. Total factor of shear force around column. Around column there are four pile. So we multiply 4 reaction. 4 into 575.25 2301 kilometer. Total parameter of length of shear area D cap plus B column. Width of column into 2 plus D cap plus diameter depth of column into 2. So we get 6380 mm. Normal shear at critical section tau V is equal to VU B dash into T. So we get VU in this VU. So we get VU and B dash and D. So we find TV 0.319 MPa. IS 456 2000 page number 58 close 31.6.3. Shear at critical section is equal to TC into KS. KS formula is 0.5 plus beta C, where beta C is shorter side of column divided by longer side of column. Therefore, the beta C to 30 by 700 mm is 230 by 700 mm. So we get 0.3285. Therefore, KS 0.5 plus 0.3285 is less than 1. So we take 1. So we take 0.825. Sorry. TC is equal to KS into 0.25 under FCK. So we get 1.134 MPa. Punching shear ratio TB by TC 0.39 and divided by 1.135. we get the value 0.2812 is less than the 1, so the design of punching shear is safe. Now check punching shear around the pile. Overall perimeter length of the pile P is pi is equal to d cap divided by 2 plus diameter of the pile plus d cap divided by 2. Is the d cap divided by 2? So perimeter length of the pile P dash is equal to we put the values and we get the answer 5.1 to 0.8 mm. Effective perimeter of length P effective is equal to 0.25 into 5120 and we get the answer 1280 mm. Punching shear section around the pile at D by 2 from the pile face. The factor shear VU is as we know 1 for 75 kN. Nominal shear critical section TB VU by P dash into D. So we put the formula and we get the 1.0196 MPa. Now we have to find shear critical section TC into KS. Same procedure. And C, check for one-way shear. Considering critical section for one-way shear at the distance of d cap divided by 2 from the face of the column along width. There is a critical section is the face of the column. We know P1 was 1 for 75 and we find the reaction. Design shear VU maximum P1, P3, P2, P4 is a one-way shear for we have to find P1, P3 and P2, P4. So we get P1, P3, P2, P4 5.5 kilometer. Effective depth of pile cap P effective is equal to 113 mm. The width of pile available at critical section P div 2250. Nominal shear critical section TB B is equal to B effective into D effective. We got the we put the values and we got 0.4525 MPa. At the proposed critical section, the available percentage reinforcement is 0.3475. Therefore, as per IS 456 2000 table number 90, TC is equal to 0.4290 MPa. As per IS 456 2000, close 14.5, page number 74. AV is a D cap. D cap is the distance between the critical section to the center of the pile. So D cap divided by 2 minus LCC center to center and center to center pile B column divided by 2. So D cap is 113 divided by 2 minus LC center to center distance between pile is get 1250 minus 230 divided by 2 is equal to A will get 55 mm. Now the position of critical section from center to center pile AB is equal to 55 mm. Shear reinforcement factor S factor is equal to 2 into B effective divided by AB. This is the formula. So we get the 41.90. Now enhance the shear strength TC 0.4209 into shear enhancement factor. So we get 17.294 MPa. So now TB is less than tau C, hence safe design. Check for one-way shear. Check for one-way shear along depth of column. Considering critical section for one-way shear at the depth of column, face of the column along depth, the critical section and the depth and the pile cap is near the inner side of the critical section. So we don't take any reaction as per IS code. Okay. As per IS code. So we take a percentage 00 and reaction we got 00. So the step 5 in plan and section, we provide the reinforcement in a T12 at 125 mm center top and T 150 mm thick PCC and T25 at the 125 mm bottom. And thank you.
वेरी नाइस, एक्सीलेंट, वेरी गुड, गुड कॉन्फिडेंस। एंड गाइस देखिए बहुत मतलब कैसे होता है कि आपने किया तो आपको एक कॉन्फिडेंस भी बहुत अच्छा बिल्डअप होता है। नो कैन ऑफ योर स्क्रीन, प्रशांत इज गोइंग टू प्रेजेंट। प्रशांत नाउ यू कैन ट्राई। प्रशांत नाउ आप ट्राई करके देखिए। एंड और भी कोई रेडी है गाइस रेदर देन प्रशांत? तो आप कमेंट कर सकते हैं सर आई एम रेडी टू प्रेजेंट। ये करना तो सबको है, तो बेटर है कि आप टाइम पर करके कंप्लीट कर लें, है ना? नहीं तो फिर हम क्या करने प्लान किया है कि सैटरडे संडे को करेंगे। प्रशांत यू ट्राइंग फॉर दैट?
Sir, I'm visible,
यस
sir.
यस, परफेक्ट। ओके, और भी कोई प्रेजेंट करना चाहेगा इसको बता सकता है, अदरवाइज आप बता सकते हैं कि बाद में करना सही है, कोई प्रॉब्लम नहीं है, लेकिन जस्ट प्रिपेयर अच्छे से करिए। ओके, यू कैन डू द फुल स्क्रीन। यहाँ पे नेविगेशन वाला कट कर दो, ये इधर से, मतलब इसको ना वो कर दो, क्या जूम कर दो थोड़ा सा, इससे
Okay.
प्रॉपर दिखे तो अच्छा रहेगा। इसको ना पीडीएफ बना लेते अच्छा रहता। ये ऐसे बनाने में इजी है क्या तुमको प्रेजेंट करने में?
Yes, sir. I am, sir. This is my first time for a presentation,
इट्स ओके, कूल कूल कूल,
sir.
रिलैक्स।
Yes, sir.
ये जो नेविगेशन का टैब खुला हुआ है कॉर्नर में देखो, इस तरफ खुला है ना, ये फाइल पेस्ट के बगल में, ये लेफ्ट हैंड में, इसको कट
जी
कर दो।
sir.
इसी में वर्ड वर्ड फॉर्मेट में ही। नो 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 नो, ये जो इधर खुला है ना नेविगेशन, हेडिंग, पेजेस, रिजल्ट, ये वाला।
Okay, 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 sir.
हाँ
Okay,
ये कट कर दो, क्लोज।
okay,
हाँ नाउ यू
okay,
कैन
sir.
प्रेजेंट, परफेक्ट।
Okay, sir. Uh, Today I'm going to discuss about the isolated footing. So we start from the isolated footing. As you already know that isolated footing is the most commonly used in the foundation building in construction. This type of foundation is specially constructed for a single column. The shape of an isolated footing is either a square or rectangle, depending on the structure column and load requirement. This is a very important thing. What is about the column load requirement? The size of a footing is determined by considering the both load on the column, shape bearing capacity of the soil. Soil bearing capacity is very important to decide the column size or a foundation or many other things. Rectangular isolated footing is chosen for enhanced stability when movements are caused by load intensity or horizontal forces. How isolated footings take a step? Isolated footing take a step in two ways: excavation and preparation, reinforcement, and concrete placement. So the construction begin with excavation the soil to a specific depth, creating a pit for the footing. Size and depth of the excavation depend on the load bearing requirement and the soil condition. Reinforcement, and after that we are doing after excavation reinforcement and concrete placement. Reinforcement bar or rebar are structurally placed within an exhibited area to enhance the strength of the footing. Concrete is poured into the form, creating a solid base. Type of design isolated footing is a rectangular isolated footing or a square isolated footing, and second is a rectangular isolated footing is most commonly used in India. Even square isolated footing. Square isolated footing is a common and practical foundation isolated footing designed to support a single column only, known as a pad foundation and characterized by equal length and breadth. The square is isolated footing create a symmetrical means even from each and every side square shape base. This type of a footing is particularly well suited for a situation where the load from the column is evenly distributed. Rectangular isolated second is rectangular isolated footing is a foundation that support structure single load, single column or a load bearing element. Unlike the square isolated footing, rectangular footing are having length and width from a rectangular shape. The design is specifically chosen when the load of the column create moment due to intensity or horizontal forces, require more stable and adaptable foundation. Sustainability of isolated footing. Thus, suitability of isolated footing is determined by various factors influencing its design and application of a construction project. Here, they are considering that determine suitability of isolated footing. First is load distribution. Load distribution. Isolated footing are good to fit for case where the weight of a single column is moderate, can effectively spread across the foundation region. They have frequently employed in the construction of house and smaller commercial building. And second factor is first factor is we learn load distribution, and second is what is the soil bearing capacity. Is a very important role for the foundation. This soil bearing capacity decide the length or width of the column and types of the foundation too. So we are discussing soil bearing capacity. The strength of soil under the footing is essential in deciding its approximateness. Isolated footing work well where the soil has enough strength to bear the applied load. Isolated column footing spacing. Isolated footing are effective when columns are placed at interval, permitting individual support. The design of a foundation consider how columns are spaced and arranged. Structure stability. The structure of a isolated footing is designed to guarantee stability to preventing excessive settling or tilting. It's crucial to consider aspects like the structure type, load magnitude, potential variation in the load distribution. Uniformity of load. Isolated footing work well when a column load are fairly consistent, avoid significant irregularities. Alternative footing type might be more appreciated in situation with a substantial load and variation. Construction simplicity. Known for their straightforward design and construction, isolated footing are well suited to the project when a simple and cost-effective foundation solution is preferred. Site-specific condition. To ensure the prolonged effectiveness of isolated footing, considering site-specific condition including environment element, potential alteration in soil property or imperative. Advantage of a isolated footing. Isolated footing offers several advantages in construction, making them a preferred choice for supporting individual column in diverse structure. The following are the benefit of isolated footing. Focused load distribution, tailored for supporting individual column. Isolated footing efficiently distribute load locally, preventing excessive weight transfer to neighboring column or area. Versatility across the construction project. These footing exhibit versatility, applying in the broad spectrum of a structure, from residential building to small commercial project. The adaptability suits various architectural design. Simplicity in the design and construction. Isolated footing are recognized for their simple design and construction procedure. The simplicity not only enhance cost effective but also streamline implementation of a construction site, reduce the risk of differential settlement by offering individualized support to column. Isolated footing mitigates the risk of differential settlement. This ensures uniform settling of the structure, minimizing the chances of uneven or tilted foundation. Convenient inspection in the maintenance. The isolated nature of this footing implies inspection maintenance issue with the specific column. Isolated footing can be addressed without impacting the entire foundation, streamlining repair and maintenance. The isolated footing is also a cost effectiveness. Means that it's very good to develop or in the term of the economy. Isolated footing are often prove more cost effective, particularly in the relative light road scenarios. The straightforward design and the construction contribute to overall project and cost saving. Effective management of eccentric load. The design of isolated footing facilitates the efficient handling of eccentric loads. This is particularly valuable in the situations where applied load create moment due to the horizontal forces and irregularity in the load distribution. And one other disadvantage of isolated footing we have to discuss. even through isolated footing have several benefits, it is important to consider the potential drawback before the construction of the project. Here are some drawback of isolated footing. Drawbacks, we can say that it's a disadvantage. Isolated footing maybe have limitation in supporting maximum load. Alternative foundation type may prove more appropriate in a situation involving heavy load or a larger structure. We can say that for a small load or a medium load, and where we have a good soil bearing capacity, so we choose isolated footing. But we have a very heavy load or larger load, or having a large structure where we have a heavy load on soil bearing capacity is not too good, so then after we choose other foundation, just like a pile foundation, raft, or combined foundation. So right now I'm just trying to explain with the help of one example how to calculate isolated footing design manually. So I'm trying to discuss with you. Sorry. Isolated footing design as per Indian standard is 456/2000 code, the structure design in civil engineering. Footing, the structure which exists below the ground level. The strength of a building is depending on the reinforcement detail of the foundation. The reinforcement detail are depend upon the total load which is act building structure. The load related to the gravity load are considered in the foundation design. The load is taken as a point load which act as a column section. It is in this article I will explain you the clear concept of regarding the isolated footing design as per Indian standard 456/2000 code by manual calculation. So here we are. So basic formula used for a design for RCC footing or RCC design. So first is area footing. How we can decide what is the area of footing, what is the size of footing? Is the total load actually when is load is coming from the column from top to bottom. So we are choosing what is the total load divided by the soil bearing capacity. Soil bearing capacity may be 150, 180, 100. So we can decide. So and we can alternatively, if we having already having a size of a footing, so we can find out what will be the bearing capacity of a soil. So total area divided by the footing. So we can find out the soil bearing capacity. Or if we having if we didn't having the size of a footing, so total load dividing by the soil bearing capacity, then we got the size. Second is the factor shear load. QU is the soil pressure. B is the breadth divided by 2. B is once again B is the breadth. C is the column size, and 2D. Third is one-way shear. How to calculate one-way shear is VC1 is tau C BD. B is the depth and D is the depth of the footing. It's the depth of the footing. Fourth is a factor shear force or a two-way shear. So QU is soil pressure, B square is breadth of the column, C is the column size, and D is the depth of the footing. Fifth one is the punching two-way shear is VC2 KS tau C B naught D. And the seventh is the ultimate moment mu is QU is a soil pressure and divided by 8, and B is the breadth and C is the column size square. And seventh is mu is equal to is the formula of calculating the steel. Mu is equal to 0.87 Fy. Fy is the yield, and AST is the percentage of steel. D is the diameter, depth, or and 1 minus AST Fy divided by BD FCK. FCK is the what is the grade of the concrete. Later on we will see. So these are the 7 steps are very important to calculate the isolated footing. A step used for isolated footing design as per IS code 456 code. First is the load calculation. Second have to the size of the footing. Third is calculation of net upward pressure at ultimate load. Fourth one is the calculation of one-way shear to determine the depth. Fifth one is the punching shear. Punching shear means that it's a point load acting on the particular footing, and two-way shear, and reinforcement design. For an example, we are taking it's as we are assuming isolated footing. Example of isolated footing design as per IS 456/2000. Design RCC isolated footing for the column size is 400 by 400, which is carry of load of 1200 kilonewton of the column. Soiling bearing capacity, we are assuming that 200 kilonewton per meter. Assume M20 is the grade of concrete, and we are taking steel 456 grade. The first calculation is the load. We are taking giving the name P is the load. Given load is 1200 kilonewton. Factor load is the ultimate load is calculating 1.5 into P. P is the load which is acting on the footing, and factor load is taking 1.5. Factor load means it is the factor of safety. In the RCC building design, we are taking 1.5 for the RCC, and 1.2 is taking in a steel construction. Second, after calculating this, we got 1800 kilonewton, and we are assuming 10% is the additional load. We are not assuming day-to-day life, so we are considering 10% extra. So we got 120. So we are calculating all these things. Then we got 920 kilonewton. Size. Second is the size of the footing. Size of the footing I already discussed. B is the width. It's a square footing. So is a B square is equal to B into B. Length into breadth. And the third is formula of area of calculating given by B square total load divided by soil bearing capacity. So what we got the latest load is final load is 920 is a kilonewton, and 200 is already given in the soil bearing capacity in the question. So after dividing, we got 9.6 meter square. So after the routing of this 9.6 meter square, we got the value of 3.1. Means that this is the B square, B into B. So after routing of 9.6, so we got 3.1 meter length and 3.1 again. Once again, 3.1 is the width. It's a width of the footing. Third one is the calculation of upward pressure at ultimate load. So soil pressure QU is equal to total load dividing by the area of footing. So what is the area of footing is 9.6 meters square, and total load is 920. When we divided, so we got 199.80. It's approximately same as what is we got 200 kilonewton meter square soil bearing capacity. We can alternatively you can calculate. Calculation of net upward pressure. Sorry, we already discussed. Fourth is calculation and check for one-way shear to determine the depth. This is the isolated footing you can see, and this is the column, and this is the base footing. And this is the reinforcement, and the upward direction showing the upward pressure, which is by the we are giving we are assuming from the soil pressure. And step 4 for formula for factor load for one-way shear. Factored shear force VU1. We already discussed about the formulas. After applying or putting the value, 0.2 is the soil bearing capacity, and B is the width. 3.1. I hope you remember 3.1. So we are in a meter. So if we converted in mm is 3100 divided by 2. Once again, B is the breadth 3100. C1 is equal to length of depth of the column, and 2 multiply by 2d. After calculating all these things, so we got this first equation 310, and this is the first equation. Second, by assuming 1% of steel in footing is 0.15%, So from table 19, we got the first value. After putting this value, we get design shear is 0.36 Newton meter square, and one way shear is formula is tau CBD. After putting this value, we got the value of D is equal to, D is the depth of the footing, 482.19. So let us cover is mostly we are providing the cover is 50 mm, but after adding this value 482 plus 50 is nearly comes 550. So we are assuming that to make it to convert into the round figure. So let us consider we are providing the cover is 68 mm. So we get 482 plus 68. We got 550 mm. This depth of isolated footing is got it. And check the punching shear or two-way shear. I already explained what is the VU U2 and Q B square and this particular formula. Applying the value of VU U2 is 0.2 is once again is the soil bearing capacity, 3100 is length or depth, the breadth of the footing, and 4 is the column size, 550 is the depth of the footing. And we got this value 741 kilonewton. Again, we have to put this value to punching or two-way shear resistance. So we got 3800 value. From clause 31.6.3 permissible shear stress, this is a IS code, Indian Standard IS code for the RCC 456-2000. C is equal to 0.25. This is what? This is C is equal to 0.25 is a concrete, and Fy is equal to 0. Fy is a half, 0.25 multiplied by 20 half. We got the value of 1.118 Newton meter square, and Ks is equal to 1. By applying all this value, we got the safe value of a footing depth is 550. So VC2 is greater than VU2. So the last second last is reinforcement design calculation. We have an ultimate moment expression for calculate section formula section. Mu is equal to the soil bearing capacity, B is a breadth of footing divided by 8, and B is a breadth once again, and C is a column size. So applying this value, we got the value of Mu is equal to 564.975 kilonewton meter. Seventh is reinforcement design calculation. So Mu is 0.87 Fy, area of steel, D is the depth of the footing, and applying all this value, we got the area of steel is 2951.4 mm square. So let us consider the 16 mm diameter bar for the footing, which is used in the reinforcement. Area for one bar is the 201 mm square. So number of bar required 2951 divided by 201 for a 16 bar. So we got 14 bar, 14.68. So we are taking in a round figure. So we calculate 15 number of bar or 15 number of steel bar of 16 mm diameter bars. Spacing area is equal to divide area of steel multiplied by breadth. So we have a final value of reinforcement is 2.211.12 mm. So the final reinforcement of isolated footing of as per Indian Standard 456-2000 code is obtained use 16 mm diameter bar at 210 center to center distance in both x and y direction. So this is on the final reinforcement view, you can see. So this is a column, this is a ties, and this is the footing. So 16 number of bar in column to center distance. Sorry, it's a center to center distance. Thank you.
वेरी गुड, मजा आया प्रशांत पहली बार कॉन्फिडेंस से प्रेजेंट करते समय?
जी सर, थैंक यू सर।
ओके जी, देखो इससे गाइस क्या होता है कि अब इन्होंने पहली बार प्रेजेंट किया, अब इनको कभी कंपनी में भी जरूरत होगी ना प्रेजेंट करने की, तो ये बहुत कॉन्फिडेंटली आराम से अपनी चीज को प्रेजेंट कर सकते हैं, क्योंकि इनके लिए वो नया नहीं रहेगा। ऑफ द, यहाँ स्टॉप कर दो, स्टॉप शेयरिंग कर दो, ठीक है, स्टॉप शेयरिंग कर दो। ओके विष्णु, आप, मुझे पता है आपको रेडी हैं, बट आपका हम लोग किसी और दिन अरेंज करेंगे, ठीक है, जिस दिन भी अपने क्लास के बाद का 15 मिनट आपको शेयर कर देंगे, उसमें आप अपना प्रेजेंटेशन कर दीजिएगा, बस रेडी रहिएगा, ठीक है। और गैस आज आपको मतलब अभी, क्योंकि मुझे पता है आपके कई लोगों के पोर्टफोलियो नहीं बने होंगे, एक आध लोगों का छोड़ के, तो आज पोर्टफोलियो ही केवल आपको बनाना है, ओनली यही टास्क है। कल पोर्टफोलियो सबमिट कर दीजिए, एटलीस्ट इतना कि हाँ स्टार्ट हो गया, फिर जब दिवाली का हॉलीडे हो तो उसके बाद कंप्लीट आए, ठीक है। यस ब्रिंजल बोलिए।
Sir, I